Satellites have revolutionized the way that we humans live. In this video, we are going to explore how satellite television works and also the big money flows associated with this broadcasting business. Towards the end of the video, we will also explain the interesting reason why there is no buffering of your TV broadcasts in the way that internet videos are buffered. To understand satellite TV broadcasting properly, we first need to have some basic knowledge about the parts of a satellite and how a satellite moves. As you can see, the Earth revolves around the Sun in an elliptical orbit, and the Earth also turns on its own axis. You can see that this axis of rotation is not perpendicular to the elliptical orbit surface, but slightly inclined as shown. For satellite TV to work, the satellite should not move relative to your house. This means that the satellite should rotate at the same speed as that of the Earth, which means it will take 24 hours to complete one cycle. Let's work out the force balance equation of the gravitational and centrifugal forces at this point, using this speed information. You can see that the orbital radius required to achieve the no relative motion condition for the satellite is exactly 42,164 kilometers. This orbit is known as a geostationary orbit. All satellites used for satellite TV purposes should be parked in this orbit, and this visual shows how crowded the geostationary belt has become nowadays. Now, let's find out a few things about the satellite itself. The energy required for a satellite mostly comes from its solar panels. However, if the satellite is not facing the sun, a battery pack helps to continue its operations. It is interesting to note that satellites have small engines called thrusters. The gravitational field experienced by a satellite is not uniform due to irregularities on the Earth's surface and the presence of the Moon and the Sun. The thruster produces a very minute amount of force to always keep the orientation and position of the satellite correct. The most important part of a satellite for communication purposes is the transponder. The transponders receive signals from the base station at one frequency, amplify the power of the signal, remove any noise, and transmit it back to Earth at a different frequency. The uplink frequency is always higher than the downlink frequency. You can see antennas of different frequency bands. For D2H, the Ku band frequency is generally used. These Ku band signals have good power, which allows a smaller size receiver antenna. In the past, C-band signals, which have lower energy, were used for television communications, and that's why huge antennas were used in those earlier days. However, Ku band signals are affected by rain, so scientists have had to overcome this issue with improvements in satellite technology. Now that we have some basic information, let's see how hundreds of TV channels reach to your home via the satellite TV technology. Consider the case of this TV channel, CNN. They have a video production facility and keep on producing content for mass viewing 24/7. We call them a program source. This channel needs to be available at the same time on many satellite TV broadcasters' networks. We call them DBS providers. To achieve this, CNN just beams their signal to their rented transponder in its geostationary orbit. It should be noted that before sending the video signals, the program source inserts advertisements at suitable points, and this is the first source of income for the channel. Now the CNN signal is commonly available at one point, and any DBS provider can access the signal once they have made a business agreement with the program source. Similarly, the DBS provider collects signals from many such channels or program sources. At their broadcast center, they club all these content together and do video formatting like MPEG compression, standardization of bitrate, and encryption of the signal. After that, the DBS provider beams the signal to their rented transponder in a satellite. A DBS provider rents many transponders to handle the huge amount of data they have to transmit. This way, around 300 to 400 channels will be available on a single DBS provider's satellite. Now the last phase in signal transmission, the transmission of the signals to the end user. Here, the end user has to angle their dish antenna towards the DBS provider's satellite. You might have seen that for different DBS providers, There are different angles for the dishes, even if the dishes are all in the same location. This is because the different providers might be using different satellites for transmitting their signals. The signals received by your dish are encrypted to prevent piracy, and only a dedicated card in the set-top box will be able to decrypt it back. Do you know that the live events you are watching on your satellite television are actually delayed by a few seconds? The signal leaving the broadcast center has to travel a huge distance via 2 satellites before it reaches you. Even though the signal travels at the speed of light, such a huge distance will cause a delay of around 0.5 seconds. Moreover, a live broadcaster may also add a specific profanity delay on top of the normal delay. Now for the interesting comparison between Internet videos and satellite TV. Both of the television and Internet technologies transmit data in a digital format, as zeros and ones. Why is there no buffering on your TV in the way that you see it on YouTube or Facebook videos? On satellite television, the broadcaster offers only 300 to 400 channels, or video streams, and the user has to select just one from this small collection. However, on the Internet, the demands of each user are very different. There are millions of videos on the Internet to choose from. This means that the volume of traffic handled by TV broadcasters is nowhere close to the level of Internet traffic, and it is this huge level of traffic on the Internet which may sometimes cause traffic congestion and buffering. This video explains how satellites play a role in television broadcasting. To understand how satellites help your GPS to work, please check our next video in this series. Thank you.